Hello everybody, you're welcome to today's tutorials class, and we are still talking about waves. And today we'll be talking about the relationship between V and lambda. V is wave speed and lambda is wavelength. I guess that you have watched other tutorials videos on waves. I've talked about the introduction to waves and also talked about the properties of waves. So for a basic and fundamental understanding of this topic, I will urge you to go to the physics playlist in my channel and watch them, and do it to subscribe to this channel so that you don't miss out on upcoming videos. Now, there's a relationship in wave physics between wave speed and wavelength. All right, so after this we're going to be taking some calculations on waves. All right, so the relationship between V and lambda is V equal to F lambda. All right, V is equal to F lambda. All right, how do we come about this? You know that velocity is equal to distance over time, right? Distance over time is equal to distance over time. All right, let's just start to the part C because we are implying period here. All right, so the distance here is something as wavelength. All right, that is the distance between two successive crests or troughs. So we have that D now is equal to lambda then over T, and from the basic understanding of waves, we know that frequency is equal to 1 over period. So here we have that V is equal to 1 over T times lambda. So V is equal to F lambda, F times lambda, F lambda. So that's how we derive this relationship between V and lambda. And guess what? You are going to be employing this formula a lot in solving a lot of questions that we are going to be doing just right away. So get ready, get ready, get ready. Get your calculators, get your pen, your book and everything. Let's go there. So example 1, we're going to solve the first question. The diagram below represents part of a wave motion in air. Okay, we are going to draw the diagram. This is the diagram. So this is 0. So this is very simple. All right, so this diagram represents the part of a wave motion in air. If the wave travels with a speed of 300 meter per second, that means the speed, that is V, is equal to 300 meter per second. All right, so we are asked to calculate the frequency of the wave. Now the length from this place to this place is 3 meters, and guess what? We need to find the wavelength, because V is equal to F lambda. Since we have the frequency, okay, we are looking for the frequency. Let's see if we can get the wavelength. And the wavelength is the distance between two successive trough or crest. All right, so, and also is the length of one complete oscillation or cycle. All right, so this is one wavelength from here to here, from here to here. This is one wavelength, 1, 2. All right, then this is just half. Do you understand? Let me mark it with a different color of my marker for emphasis. So this is 1, 2, So we have 2.5 number of waves. All right, 2.5 number of waves. Now we can do a comparison. We can do a proportion here, and we can say if 3 meters, okay, if 2.5 number of waves is equal to 3 meters, all right, how many, like what will now be the length of one number of wavelengths? All right, so 1 will now be 3, so we can cross multiply, so we can call this n, sorry, that's one wavelength will now be equal to what? N or x, yeah. So x is obviously equal to 3 over 2.5, which is 1.2 meters, just if I'm not mistaken, yeah, 1.2 meters. All right, so v now 300 is equal to 1.2 lambda, so lambda is not equal to 300 over 1.2. all right, which is something as 3000 divided by 12, okay, which is 250 hertz. 250 hertz. So the answer is what? 250 hertz. Do you understand? Okay, so if this is the length of 2.5 or 2.5 wavelengths, okay, so we are going to find the length of one wavelength. All right, so we did this by proportion, and we were able to get the wavelength to be 1.2 meters. All right, so that's actually it. Then we now impute it in this formula, and we got 250 hertz. Do you get? There's also another method that we could have used. That's just using ratio. All right, you're still going to get the same value. So I'll teach you that, so that maybe if you have a question like this, you can employ anyone that you want. All right, so we have that the speed is 300, okay, and the distance here is still 3 meters, right? Yeah, 3 meters, okay. So remember, we got 250 years at the answer, so let's try to get it again. If the wave travels with a speed of 300 meters, then calculate the frequency of the wave. All right, so since we are going to compare when we have 2.5 wavelength to when we have 1 wavelength. All right, so when we have 2.5 wavelength, the distance is 3 meters, okay, the distance is 3 meters, so this is 2.5 is to 3 meters. All right, so we are going to get 1 is to x. Do you understand? So we have 2.5 over 3 equal to 1 over x. The same thing that we did, we can still get x to be 1.2. Instead of using the proportion method, we can use basic ratio, and we get the value of x, and then use it to compute with the velocity or wave speed. Do you understand? I hope this was very clear. If you have any questions, do well to ask in the comment section. I'll be there to answer. All right, so